before we go any further with the notebook, I would like you to get out your yellow sheet because I want to make some updates to it now that you have 4 different things to choose from. Okay, so these are things I'm going to allow you to have on your yellow sheet. And so this, you should make an arrows 1 sample z-test for P. And this is the reminder that you use P when you can. This one we use for 1 sample z interval for P. That's chapter 8. This is chapter 9. Okay, and then back to chapter 8 again. This one here is the 2 sample z interval for P1 minus P2. And then, as you can probably suspect, the one underneath it, hold on, let me just slow my roll a second here. Yeah, yeah. There's no 2 sample z test. And what I want you to do is put 2 arrows. So you're going to put an arrow to this and an arrow to this. And this is what we're going to be using today. Today is what we're learning, the 2 sample z test for P1 minus P2. So I'm hoping that by having these arrows on here and practicing this, that when you take the AP exam, you'll know where these things are located just because you've had all the practice of it. And keep your formula sheet next to you for this because this is a little bit different. It's got a little bit of a quirk to it. So let's move that off to the side. Okay. And then finish the conclude. You guys probably did not write the conclude in your notes. And then the example, the arts and crafts comes right after that. I don't know why I left 3 lines there. You do not need to leave 3 lines there. I don't know what I was thinking, but it's fine.
Oh, very.
The world today, something. And then like. Yeah, and then. You guys ready? You sound ready. Your underlying roarish sound. Make you feel like you're ready. Yeah. I'm so glad that you didn't have to handwrite all of that. Thanks to Mr. Talbot. He's the best. Okay, anyway. Okay, let's read it. 123 children were volunteered for an experiment. That sounds morally suspect. 4 children. 62 were randomly assigned to attend preschool while the others did not attend. This sounds life-changing. Of the 62 who attended preschool, 38 ended up needing social services later in life, and 49 in the non-preschool group ended up needing social services later in life. Okay, we need to talk about this. You're going to see these words next to each other all year. This is not grammatically incorrect. Do the data. Data in this case is plural for data. This is the plural data instead of the singular data. Do the data provide convincing evidence that preschool reduces the need for social services for children like those in the study? Okay, so scrolling up here, it says that for the state, you state the hypotheses and both parameters of interest and alpha. Okay, so I know I need 2 hypotheses. I need a null hypothesis, which I lovingly refer to as the HO, and I need an alternative hypothesis that I lovingly refer to as the HA. Okay, I know that my hypothesis needs to be stated in parameters, and for this, I'm going to go back to the definition of null hypothesis. It says the claim that we weigh evidence against, statement of innocence, or no change, or current claim. Okay, would it make sense to you that my null hypothesis would say that there is no difference? Wouldn't that be no change, current, nothing's happening here, nothing suspicious? Okay, now how we're going to write that is P1 minus P2 equals 0. Every single 2 sample z-test for P1 minus P2 has the same null hypothesis. P1 minus P2 equals 0 every time, every single one of them. Why? Because you're assuming no difference. Can you guys read this and say the difference is nothing? No difference. Okay. Now we're going to figure out what this would be. And the only change here is you're either going to have a less than, a greater than, or a not equal to. And we have to use the wording, and the wording is right here, reduces. P1 is the preschool group, and P2 is the non-preschool group. So we're saying reduces P1 is less than P2. So the preschool group needs services less than the non-preschool group. Okay, what you're going to do is subtract P2 from both sides and make that less than. Do you see what I did? I subtracted P2 from both sides in my mind and made it P1 minus P2 is less than 0. Or you could just be like, oh, it's got the word reduce in it, so it's probably less than. Now, if this part's hard for you, there's going to be a check that you can do later on in the problem to make sure that your arrow is going in the correct direction, which is excellent. Okay, now we're going to go back to the defining the parameters. We have to define them both. That's one of the things that's annoying about these is that because there's 2 samples, you have to do 2 of everything. So P1 equals the true proportion of volunteers who attended preschool and needed social services later. P2 is the true proportion of volunteers who did not attend preschool and needed social services later. Yikes, that's long. Okay, now before we move on, what is the alpha level in this problem? No worries. Anybody? Anybody? Hold on. Let me show you some notes. This one, use this one if you're not given alpha. Always use 0.05. It's a nice middle of the row. Okay. Plan 2 sample Z test for P1 minus P2. There's my method. Is there some random assignment in this one? What does that mean for us if it's randomly assigned? Yes. Okay. All right, so this is where it gets new and exciting. If you are assuming that there's no difference between the two proportions, what they do in stats is they pool them together and makes it into one big sample. So can you guys find on your formula sheet, on your yellow sheet, the formula for the pooled proportion? It was one of our little arrows we wrote a minute ago. He's right here. Okay, this guy's name is p hat pooled or p hat combined. It's a C for combined, but you always hear it called pooled. I don't care if you say pooled or combined, either one is fine. Okay, this is the success of the first sample plus the success of the second sample over the total of the first sample plus the total of the second sample. Okay, so we're going to find that first. So we're zooming out here. What is the success from the first sample? 38, right? Do you guys see the 38? Okay, so we have 38 plus, and what's the success from the second sample? 49. And remember when I say success, it doesn't always mean it's a good thing. Meaning social services is not necessarily a good thing. So when I say success, I'm saying it in a mathematical standpoint. Okay, over. What's the total amount in the first sample? 62. Total amount in the second sample, 61. It's 61, right?
Yeah.
Okay. I'm just gonna throw that little calculation up there. Okay, so 38 plus 49 divided by 123. Oh, it's our area code, 0.707. Okay, so we're gonna have to do 4 calculations and I'm gonna have to shove them all into this little tiny space. So I have N1 is 62 times P hat combined, pooled, greater than or equal to 10. 1 minus. Oh, this is bad. You guys know where this came from? You do? So first sample, n times p, n times 1 minus p. Second sample, n times p, n times 1 minus p. Okay, anyway, do you guys trust me to get the numbers from my previous calculations? Okay, so this one right here is, I'm gonna go above it, 43.8. This one right here is 18.2. This one here is 43.1. And this one is 17.9. You also know that if this was not random assignment, you would have to write 2 things for the 10% condition. Let's just pretend we were going to write it. We would say N1 equals 62 is less than 10% of all. Doesn't make sense, but preschool attending children. And then you'd say N2 equals 61 Anyone? Anyone here? Okay, just check, just check. Mhm. Yeah, sure. Okay, so this part right here, I just got straight off of the yellow sheet. Standardized test statistic equals statistic minus parameter over standard error of the statistic. Okay, and now we need to figure out what we need for this problem. This problem, the standardized test statistic is Z because that's what we're working with. And we're going to go over here. The statistic, I'm going to say stat, is p hat 1 minus p hat 2. So what you do is you take the parameter from the null hypothesis and you just put hats on it. Okay. P hat 1 was 38 over 62 minus, and then P hat 2 was 49 over 61. And that comes out to be negative 0.190. Okay, so I'm going to take this negative 0.190 and plug it in right here where the statistic is. Okay, minus. We good? No? Yes? Okay. Parameter is P1 minus P2 without the hats. And if you look at the null hypothesis, that is 0. And it's going to be 0 for all of them. All of them are going to be 0 because the null hypothesis is 0 for all of them. Okay. Over. Standard error of statistic. Okay, so then we go here. We're doing a two sample z-test for P1 minus P2, and we plug the things into this formula. Okay, so P hat C, that was our area code. Do you guys remember the area code thing? Okay, times 1 minus P hat C times 1 over N1 plus 1 over N2. Okay, and really, this is just the same thing as the previous ones, just that these two are the same, so they factored them out in the front. It's not a big deal. Okay, so I'm gonna go square root. You guys might want to practice with me. 0.707, 1 minus 0.707, 1 divided by 62 plus 1 divided by 61. Okay, do you guys all see what I did in the calculator? So I typed the whole bottom dealio, and then I did that divided by that. Okay. Okay. Now, this is where you guys said, I said earlier, you're going to be able to check to make sure that your direction is correct. You see how this is negative? So where does a negative live on the normal curve? Over here, right? Does that make sense? Okay, which means that you're on this side, which implies less than. So you want to take this moment and go, okay, let's just check. Did I write the right thing in my hypothesis? Oh, yes, it's less than. So if it's less than, you'll notice your z is going to be negative. If it's greater than, you're going to notice it's positive. You'll be able to check yourself as you go through. Okay, anyway, negative infinity, negative 2.3101. Hmm. Is it less than or greater than alpha? Less than? I'm hoping we all know that 0.01 is less than 0.05. Okay, but what do we do with that information? If the P is low, reject. Yep. Mm-hmm. That means we have convincing evidence of the ha. So I'm going to say we have convincing evidence, and then I'm going to look back at the question. Going to take the words convincing evidence, and then I'm going to copy off of the problem. So that preschool reduces the need for social services. Okay, last two questions of the day. Based on your conclusion, could you have made a type 1 or type 2 error? Okay, this is where you're going to use Mrs. Talbot's patented dumb way to remember the difference between type 1 and type 2. Yeah, if it was failed to reject, it would be type 2. But this one's just reject, so it's type 1. Let me say that again. If it was failed to reject, it would be type 2. But it's just reject, so it's type 1. Since we rejected the hoe, we might have concluded that preschool reduces the need for social services when it actually doesn't. How sad is that? This problem is depressing. Like you send all these kids to preschool thinking it's going to help them, but then it really doesn't. I actually still think preschool helps, regardless of this contrived stats problem. Anyway, okay, last thing. And the last thing is actually a chapter 4 question. It's not a chapter 9 question. Can we generalize the results of this experiment to all children? Okay, I'm going to find you something to help you answer that. It's in your blue sheets with all your definitions on it. Okay, here you go. Gonna let us look at this. Okay, so random sampling allows us to generalize the results of the whole population, but not establish causation. Random assignment allows us to determine cause and effect, but only for those individuals like those experimental units. Okay, what did this problem have? Random assignment. So can we generalize the results of this experiment to all children? No.